Morning sir, this is Jayprakash from ECB section and the roll number is 499. The similar topic is GNR diodes and its breakdown mechanism and practical applications. Introduction to diodes. The foundation of the semiconductors electronics. Diodes are fundamental semiconductor devices acting as one-way values for current flow. They form basis of modern electronic components. Current flow control to allow the current in one direction blocks in reverse. And the PN junction formed by joining the P-type and N-type semiconductor. What is the GNR diode and a specialized PN junction? A PN junction is a special type of diode designed to reliably permit current to flow in the opposite direction when a certain reverse voltage is reached. This is called the GNR voltage. Heavily doped PN junction operates in reverse breakdown region. Precious breakdown voltage and the GNR diode symbol is having two ends, anode and cathode. Diode biasing forward and reverse and the path to breakdown. Understanding the how diodes are biased is crucial to grasping GNR diode operations. Forward bias voltage applied in the same direction, and the reverse bias the voltage applied to opposite to current flow. Breakdown excessive result reverse voltage causes conduction. GNR breakdown mechanism and the quantum tunneling effect. GNR breakdown is prevalent in diodes with heavily doped junction and narrow depletion regions. High electric fields across the narrow depletion region cause electrons to tunnel from the valency band to conduction band. Even without gaining sufficient kinetic energy, avalanche breakdown mechanism impacts ionization and carrier multiplication. Avalanche breakdown occurs in diodes with lightly doped junction and wider depletion regions. Number 1. High electric field accelerate minority carriers. High electric fields accelerate minority carriers, impact ionizations and carrier multiplication, sudden current increases. High electric fields it accelerate minority carriers and the impact ionization collisions knock off the electrons and the carrier multiplication it creates a cascade of free electrons and holes and the sudden current increase leads to breakdown. GNR diode characteristic the VA and curve and the breakdown voltage. The VA curve uniquely defines a GNR diode behavior. Primary applications, voltage regulations and stabilization in circuits. GNR diodes are indispensable for maintaining a stable output voltage across a load even if input voltage or load current changes. It parallel to loads, it acts as a shunt regulator. It absorbs excess current. It provides a steady DC output. It ensures the sensitive component receive a consistent voltage, protecting from the fluctuations. GNR diode varying display spikes. Further applications refers voltage generation and over voltage protection. Beyond regulation and GNR diode offer crucial financial in other areas. Reference voltage, over voltage protection and wave shaping. Reference voltage is precious and stable reference for measurement and control circuits. Over voltage protection clamps voltage spikes protection sensitive circuits from damage. Wave shaping it can be used in modify AC waveforms. GNR diodes are an indispensable component for robust electronics and Q1K. GNR diodes are small but might offering stable protection in a vast array of electron systems. Key attacks control the breakdown voltage regulations and diverse applications. When PN regions are heavily doped, direct rupture of the covalent bonds takes place because in applied voltage this process creates large number of electrons. hole pairs and the newly created electrons hole pair generates large reverse current. For heavily doped junction, the depletion region with it is very small, and as result of fluid across the junction because very high and its conduction diode breaks down, and this is called as Zener breakdown. It occurs for reverse voltage less than the avalanche breakdown less than the 6, and it impacts enable reliable and efficient circuit designs.